Hello, everyone. Today we're going to talk about parallel lines and proportional parts. So I want you to start by pausing and doing number 1. This is a review of our side splitter theorem. So our side splitter theorem says that when we have parallel lines that cut a triangle, that the top portion of one side or the bottom portion of one side is equal to the top to the bottom of the other. And then we solve that by cross multiplying. And then we solve the equation. And we found x equals 2. So why we're reviewing the side splitter theorem is because today we're going to talk about the corollary of the side splitter theorem. And the corollary says if 3 parallel lines intersect 2 transversals, then the segments intercepted of the transversals are proportional. So here we look at that this is a triangle, and I have 3 parallel lines. This would be bisected, or not bisected, but intersected, so that AB to BF is equal to AD to DG. It also works that I can say BF to FC is equal to DG to GE. So we can use that over here in this diagram to find y, because we have 3 parallel lines. So knowing that we have 3 parallel lines, we're kind of looking at this bottom portion here where we didn't use the triangle at all. So we can say that 16.5 to y is equal to 15 to 26. And there again, we cross multiply. So we cross multiply, we get 15y equals 429, divide both sides by 15, and y equals 28.6. So use the figure to the right to find the missing portion. So if we look at number 1, we're talking about AD and DG, and then EH. So the part that would go above EH is BE. So I want you to pause, and I want you to try 2, 3, and 4. Okay, so I'm going to stop there so you can see how I color coded. So I colored in CF and BE, and then FI, and found out the missing part is EH. And then I did the purple, so it's AD to the long part AG, and then the long part BH, so it's the top part BF. So now I'm going to erase this stuff because it's getting kind of crowded over here. And I'll do the last one. So it's GH and HI. So that's going sideways. So I need to take into account a whole part of a triangle, because that's the bottom of a triangle, and that's part of my parallel lines. So the only triangle I could really do there is JG. And then it's similar to, so I'm talking about this triangle. Is similar to this triangle because and actually upon closer examination, we haven't learned how to do number 4 yet. That's coming later in this lesson. All right, so next what I want you to do is I want you all to choose to do a group. Pick whichever one you want. Do group 1, 2, or 3, and then come back and we're going to compare what we found for the three groups. Okay, so I found E to be 5, 7, F to be 8, 1, and G to be 3, 2. Doesn't matter which 2 points you used, they should have worked out to be the same as your group 1, 2, or 3. So now using the distance formula, I want you to find the length and follow along with your group, whether you did 1, 2, or 3. So you're going to find the length in group 1, AC and EF, group 2, AB and FG, group 3, BC and EG. So pause and do those and come back. Okay, so group number 1, you should have found AC equals square root of 180, which simplified as 6 radical 5, and EF is the square root of 45, which simplified as 3 radical 5. Group 2 should have found AB is 2 radical 26, FG is radical 26, BC should have been 2 radical 29, and EG is radical 29. Now I want you to continue again with your same groups, and I want you to find the slope. So you're going to find the slope of the 2 lines you just found the distance of. So pause and find your slopes. Okay, so again, group 1, AC, the slope is -2. EF, the slope is also -2. Just trying to fix my 2 there. AB, for group 2, slope is -1/5. FG, the slope is -1/5. Group 3, BC, the slope is 5/2. EG, the slope is 5/2. So now we're going to define something, and a midsegment is a line that joins 2 midpoints of a triangle together. So therefore, EF is a midsegment, FG is a midsegment, and EG is a midsegment. So I want you to pause, and I want you to think what you think based on the results we found using the distance formula and the slope formula, the midsegment theorem is. So what the midsegment theorem states is the midsegment of a triangle, right? Because we did the midsegment of a trapezoid already. The midsegment of a triangle is parallel to the third side so the one that it's not the midpoints of, and half its length. So the midsegment theorem of a triangle is the midsegment is parallel to the third side and half its length. So we can use that to do problems like these. So number 1, we have triangle LOB. A, R, and T are the midpoints. LB equals 19. LO equals 35. And QB equals 29. We want to find the 3 sides. Well, RT is the midsegment that's parallel to LA or LB. Therefore, RT is half of 19. So it's 9.5. AT is parallel to LQ. So it's half of 35 or 17.5. And AR is parallel, and switch colors, to BO. So it's half of 29. So that's 14.5. So I want you to pause, and I want you to answer questions 2, 3, and 4. Come back and check. Okay, So on number 2, based on the segments, GH is a midsegment, HI is a midsegment, and GI is a midsegment. Therefore, GH is parallel to AC, GI is parallel to BC, and HI is parallel to BA. Based on that, BAC would also be 42 degrees because parallel lines corresponding angles are congruent. In number 3, since we know QR is the midsegment is half the line it's parallel to, so it's half an NM, therefore NM is 18. So to find the perimeter, we just add 18 to 12 to 31 and we get 61. In number 4, PQ is clearly the midsegment because it's connected by the midpoints. So that means PQ is half of XZ. So I did 2 times PQ equals XZ. Therefore, X equals 3, PQ equals 3, and XZ equals 6. So our last theorem of today is the triangle angle bisector theorem. If a ray bisects an angle of a triangle, then it divides the opposite side into 2 segments that are proportional to the other 2 sides of the triangle. So if we look at number 1, knowing that this bottom whole thing is 15, this little part over here would be 5. So then 10 is to X, as 5 is to 13, because that is an angle bisector. Only works when it's an angle bisector. So to solve that, I cross multiply, so I get 5x equals 130. So we divide, x equals 26. So here, when we look at these, we know that these 2 triangles are similar because they're both formed by angle bisectors. So we can write the proportion that 24 is to X, as 10 is to 8. We cross multiply. That's 192 equals 10x. Divide by 10. X equals 19.2. And those angles are equal. So here we're using the 3 parallel lines. So we know 1 is to 2, as 2 is to X. We cross multiply and we get X equals 4. Here to find X and Y, again we have 3 parallel lines. So I'm going to say X is to 21, as 36 is to 20. And we cross multiply and we get 20x equals 756. Divide by 20. And x equals 37.8. So pause and try the last 2. So our last 2, proportion, x is to 42, as 30 is to 45. Cross multiply, x equals 28. Here, x minus 1 is to x, as x plus 2 is to x plus 4. Cross multiply. When we solve it for 0, our x squared is actually omitted, so we just get x minus 4 equals 0, therefore x equals 4. If you have any questions on any of these, please bring them to class.